Hello, everyone.
Good afternoon and welcome to today's Electronic Design webcast. Our topic today, Automotive Imaging Radar for ADAS Applications, sponsored by Texas Instruments. I'm Bill Wong, Senior Content Director for Informa's Design, Engineering, and Sourcing Group. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit F5 to refresh your webcast console. If you need assistance solving common issues, please click on the yellow Help icon below the slides. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the Submit button. Also, please be aware that today's session is being recorded and will be available on the Electronic Design website within the next week. Now let's meet today's speaker. Amit Benjamin leads the millimeter wave RF CMOS radar sensor product definition and key customer engagement in the automotive ADAS market. Professional experience also includes roles in system engineering and sales management. Now let me turn things over to our presenter. Amit, the floor is yours.
Thank you very much. Hello, everyone. Great having you in our webinar. I think that imaging radar, or in general, the front long range radar, is exciting technology, and Texas Instruments is we're having lots of fun working on this technology with you, and we're looking forward to work more. Today, I want to spend time looking on the trends, technology trends, market trends that we have in front long-range radar, and in specific in the imaging radar. TI is doing great efforts to take this imaging radar, very complicated technology, and we're trying to make it easier for adopt, because we do believe it is a very important technology for the ADAS, making the ADAS system safer. So let's look on what's driving today the front radar market, and really have a very, very steep hockey stick growth. Right? So we can see that safety measures like the autonomous emergency braking and the automatic cruise control are already required in level 0 safety. So today, any new vehicle that will release to the market will very likely have a front radar sensor in as part of the safety measures, right? So that definitely drive the adoption of the sensor, of the front radar sensor in the vehicle, not just from the fancy level 3, level 4, level 5, but already from the high volume mass production level 0 vehicles. So looking on the NCAP, pursuit of Vision Zero, right? We see applications, definitely application like the AEB head-on, right, for highway, is already required and start being tested in 2020. But also, what's happening? I lost the slide. Oh, but also from the urbanic scene, right? Applications like the AEB, vulnerable road user, from bicycle and junction crossing, all of these safety measures required also much higher performance radar sensor. And today we already see 20 OEMs that are already committed to add the AEB system as a standard safety equipment in their vehicles. So what it does, it definitely contributes to a very, very nice growth in the front radar application, and again, not just from the autonomous driving perspective, but also from the ADAS systems, and that will just make all our life more safer because we will drive with vehicles that are more equipped more equipped for a safe drive. The other thing that it's nice to see here that still the front radar is led by performance, right? So still performance there are much more important than cost. So you can see that although front radar is in volume is smaller than corner radar, the dollar amount that front radar generating is higher or maybe equal to the corner radar, which really tells us that the margins, these sensors are still being sold in a higher dollar amount compared to corners. And we do see many tier one start ramping up and they started with corner radar, but now they're moving to work on front radar, where now that they feel much more comfortable with the radar sensor design. Yeah, right. So yeah, just to show a look on the urbanic area, showing how important is to increase the resolution of the front radar in order for us to really see nicely all the different vulnerable road users in the scene. Few of the technology trends that we see that are driving the front radar development are the need to measure the height, right? To be able to decide if we can go underneath the bridge or not, right? The need for higher resolution in order to discriminate a nearby object in an urbanic scenario, but also in highway, right? When we approach to a traffic jam and we need to differentiate between the different cars in the lanes, and the need to do the fusion with the image sensor and to use deep learning or artificial intelligence for classification. All of that driving very nicely the front radar technology, and I will show how TI is handling these requirements in the next few slides. So where's TI in the whole thing? So TI just released the first generation products, either from the pure front end, right? Having the RF front end with pulling out the raw data with the CSI interface 1243, or having the system on chip, which integrated, and TI is the only company today to integrate all the sensor functionality into one device. If it's the RF front end, the DSP, the safety MCU, the embedded memory, the radar accelerator, and the crypto accelerators, everything integrated into one device, right? So today, for front radar, we typically see the front end, it plays a role, right? And the reason is that the front radar is really defined to handle the extended range and the max velocity that's needed for front radar. So 1243P, which is the device that is released to market today, is the very wide IF bandwidth, 50 megahertz, and the better phase noise, lower noise figure, and higher output power compared to other sensors today in the market. So definitely a device that is leading today in the market for the front radar, but also for corner, right? So nothing stop taking this device to corner device and front, as well as imaging radar that we'll show later on. Another thing that this device is enabled is the ability to generate up to 2,000 different chirps, right? So it has a very, very nice flexibility in the amount of chirp that you can configure, and that's really take out the processor from the equation, right? So the processor doesn't need all the time to toggle the SPI bus to generate the different chips between frame to frame or between chip to chip, right? You can program the chip into a local memory of this device, and the device can work by itself. So significantly reduce the amount of computing power that the host is required to do. A couple of applications that this high performance allows us to handle. One application is the R79, where we need to identify the motorcycle from a 170 meter approach to us in 130 kilometers per hour. So the very nice RF performance of 1243 enable it to detect objects from 200 meter while using the enhanced RF performance of 12 dB noise figure, 12 dB output power, and 95 dBc per hertz phase noise. This device also have the ability to control the phase shifters in a 6-bit resolution, right? So we are able to generate a beam forming and steer the beam in a 6-bit resolution. So that's really allowing us to answer this application requirement without needing to do any trade-offs with the antenna footprint. Right, so definitely you can get to the 170 meter with a higher gain, narrow beam using a antenna footprint, but that will cost you in the field of view, right? So with this device, you're not required to do so many trade-offs on your antenna footprint to answer these requirements. The other thing that this device enable us to address is the imaging radar market. So we see the need for enhanced range and enhanced angle resolution radar sensor already required in the NCAP market, right? Not just in the autonomous drivers like level 4 and 5, but already from level 2 and level 3, you can see that advanced safety measures like automatic emergency steering are required already by 2022, right? So to meet these very advanced safety measure, the most economic sensor to address that is the imaging radar, right? With the enhanced angle resolution. Now, we do see that we do understand that imaging radar is still considered complicated in today's market, and this is why TI has developed very nice tools to make this development much more simpler and much more accessible for you guys. So what is imaging radar? We believe that imaging radar is a game changer, right? Today, the sensors that you have deployed today in the field are not capable of differentiate between two static vehicles in different lanes, right? And this causes many times for the system, for the fusion system, to completely ignore the radar today and ignore the radar from the static environment reading while the vehicle is moving. Imaging radar going to change it, right? With the 4-chip cascade that we released, development kit that we just released, we are able to go down to 1.4 angle azimuth angle resolution, and that allows us to differentiate from 100 meter between two static cars in our lane, or between the vehicle to the guard rings on the side. And that's really can enable now the radar sensor to become the primary sensor in the vehicle, right? Not like today that today the image sensor is the primary sensor, right? And most of the decisions are being taken by the image sensor. Now with the enhanced angle resolution, the radar can become the main sensor in the vehicle, and then we're going to have a much more robust sensor, right? Because the radar sensor is the only sensor that is keeping its performance in winter, in snow, rain, and different visibility conditions. So in order to make this complicated design more accessible to the broad market, TI is the first one to release to market the imaging radar development kit based on the RF board that shows 4 chips cascade together and able to work as a one unit to be able to reach up to 350 meter range with beamforming, and down to 1.4 degree azimuth angle resolution. All of the design files, all of the algorithms, everything that is needed to start designing a imaging radar or cascade product is online. TI believes that we are sharing all our knowledge online in order to make it easier for our customers to have a first step into adopting this technology, this very, very important technology. This kit enable driving for 40 minutes and capture the raw data into a SSD card. So between the RF board to the DSP board, there is a SSD card that plugs and allows to store the data, the raw data, and later on allow you to do the post-processing and run your algorithms in a MATLAB environment. We also, so one use case is a capture use case, storing the data into SSD and then run post-processing. The other use case is doing a real-time processing, running the MIMO and beamforming algorithm in the TDA2 processor. That's the board that's underneath here, and it's a little bit hard to see. Again, we have a video online, and we have all the documentation already online. And if you are interested in purchasing this kit, it's available online. Few of the challenges that we are solving with this kit is we have a very, very detailed a design guide showing how to synchronize multiple radar front ends, showing how to do the chip configuration for MIMO and beamforming, showing different techniques, showing how to calibrate the board to the board side, right? All of that is detailed in the TI design. We have a very detailed explanation on the memory bandwidth required, showing the antenna footprint mapping that we choose. Of course, that is the first step for you guys. I'm sure that you will have a more dedicated antenna footprint to your application. But that just gives the first step. And then we're also discussing on the processing flow, how to process the 192 virtual antenna channels that we have on board, and eventually, anyway. So few performance that we're showing based on this kit is, you can see here the ability to differentiate from 112 meter of 2 parking vehicles right, showing the performance of the board to go down to 1.7 degrees azimuth angle resolution. Another scene that we created, and it doesn't move. Okay, another scene that we created, and you can also see that in a video that we have online, is the ability to differentiate between the parking vehicles here to the guard rings, the ability to see the contour of the bike, the contour of the vehicle, and really start showing you how the radar sensor, how the imaging radar sensor starts showing a much more a real view of the scene around us, right? And showing really give the backup to what we're saying, that the imaging radar sensor will become the primary sensor of the vehicle. Here we're taking the Doppler data and relay that on the static environment, and in the video you can see it also moving in real time. The other thing, so one thing that we highlight in this video is the MIMO performance, going down to 1.4, 1.7 degree angle resolution. The other thing is the extended range that we gain with beamforming, going up to 350 meters, and the ability to jump between beamforming, 350 meter beamforming, to MIMO between chirp to chirp, right? So we are tracking the vehicles that are driving away from us in one chirp, and then in the next chirps we are tracking the pedestrians that are walking next to the sensor, right? Really giving us a nice indication how the digital integrated sensor is able to fully control the scene, all of that without needing the processor to exercise the SPI. So a few of the other platforms that you can find online. Again, TI is putting a lot of effort to trying to make your life easier, right? We put all the algorithms, all our EVMs. We're trying to make EVMs dedicated for the end equipment, right? And we put both the hardware and the algorithm, everything online. In order for you, we're not trying to replace you guys, obviously. We're not trying to make the product, but we are trying to make it easier for you to do the first step with us, and then take it from there and concentrate on your IP and to gain fast time to market. In addition, we have a wide ecosystem, different partners. Each partner has strengths in different fields, so I encourage you to work with us, tell us what's your goal, and then we can probably have a good clue on which third party can be the best fit to help you achieve these objectives. So to summarize, and this is a little bit, there are many details on this slide, but I think it's important. I think TI competitive advantage comes from our performance, right? If it's in the signal processing, safety, security, our products touching all these major fields. We are trying very, very hard to make our portfolio as scalable as possible. So if you invest in one device, you will be able to scale your investment to all the different sensors we have in our portfolio, right? So we're trying to prevent you of inventing the wheel every time from scratch, right? This way you can focus on your IP or not on how to work with our device. From time to market, TI is a leader in the RF CMOS market, and we are the first one to release the system on chip. Our devices are online. We already have hundreds of devices driving, and so that's from reliability perspective. We already passed all the qual, and our devices are very mature and ready for the automotive and industrial market. Thank you very much. Ready for your questions.
Excellent. A few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the question window on the side of your screen and hit the submit button. While we're answering your questions, please complete the feedback form, which is located at the bottom of your screen. So for our first question, what's the max distance imaging radar can currently sense?
Sorry, the max distance?
Yes.
Yeah, so right now we are showing on our video with the imaging radar a 350 meter, but we can probably go further than that. We stopped there because this is the requirements we see currently in the market. We probably can sense further than that. Maybe on our next video we will show that. We'll show 400 meter.
All right. Does radar have accuracy issues in any weather types?
No, I don't think accuracy is a function of SNR, and radar sensors are not, the radar sensor performance are not degraded from weather.
Okay. What makes you believe TI will lead the front in the radar market in the next few years?
So I think today from RF CMOS, we see RF CMOS start gaining a lot of traction in corner radar initially, and now it's moving very, very strongly also to front radar application. TI today is the leader in RF CMOS millimeter wave ICs sensor in the market. So the fact that we're leading this domain and the fact that RF CMOS gain a lot of traction today in the market, I think give us a good feeling of TI direction into this market.
Okay. What are the advantages of RF CMOS compared to silicon germanium sensors in front radar applications?
So silicon germanium for many years had leadership in RF performance, right? While its digital integration, so the ability to integrate the microcontrollers and different digital features were a disadvantage for this technology. Now with our first generation RF CMOS products, and definitely with the generation that will follow, we believe that we already meet or outperform the RF CMOS performance of the SiGe sensors, and we are much more advanced in our digital feature integration. So for example, we are integrating many of the functional safety monitors that allows much safer function, right? So our products are ASIL-B certified, right? So and as well our ability to generate a high number of chirps configuration give us a very nice advantage over SiGe.
Okay. Well, it's time we wrap up at this point, and those questions that we did not get to will be responding via email. On behalf of Electronic Design, I'd like to thank Texas Instruments for sponsoring today's event, and of course to all of you for joining us. Have a great rest of the day.
Thank you very much.